Oh, dang, we're live. Peace and long life. Live long and prosper. Okay, I thought I'd do something interesting today. And I don't know how it's going to work out, but I got a big old piece of paper here. And we're going to draw ourselves a wiring diagram, we is. Okay, headlights, generator, starter, battery, voltmeter, light switch, key switch. It's backwards here because I'm doing the doodad thingy. Steering wheel, seat, tires, tail light. It's all reverse. So tail light's supposed to be on the other side, but it's not going to be today, okay? Now, what I didn't do yet was, I'm going to do it on the left side for today. Distributor. We only have a 4-cylinder, so it's going to have 5 posts. And it's going to look like an idiot. That has 2 eyeballs. Okay? Oh, forgot one other thing. An ignition coil. There we go. Okay. Distributor, ignition coil. So how are we going to start this thing? You got a tractor you want to wire, and somebody said, well, ask me about, show me your wiring diagram. Are you kidding? I've wired so many things over the years off the cuff that you can't believe it. And when I get into the heavier stuff, industrial and other things, I want a wiring schematic and a diagram. What's the difference? Schematic is, think of the word scheme, like you're scheming to do something. Yeah, same idea, like you're scheming to rob a bank or something. Well, you're scheming to put the wiring together. The schematic is an idea of the functionality of how it operates, not where everything is, but they'll put it on the page in a manner that you can follow the wires so that you can see how things function and how they're connected, basically. And rarely does it have anything to do with where the part is or the wire on the machine at all. This, however, is a diagram, at least a rough representation of how things are and where they are. Now you'll say, well, what's the big deal? They're both the same. No, they're not when you get into the technical side. You walk into your local dealer, you need to be sure what you're asking for. Because some of the guys know this stuff well, but they don't know what you're asking for. They don't know what your definition is. Just remember, this is a diagram. The schematic makes no sense except how it's connected together. The schematic is excellent for troubleshooting. This is the one most often needed for repair. The diagram, repair, troubleshooting, schematic. Schematics usually have specs and other things that are in there that the diagram rarely has. But you'll find some diagrams that'll tell you 12-volt coil, 6-volt coil, battery, and such. But usually that's in the schematic or in the schematics legend because the page is so busy with other stuff. There's often not much room to put it in there. If I go to work on an excavator and ask for a hydraulic diagram, worthless. Absolutely worthless. In fact, most of the time you don't even know where to put the hose that you're looking for because it's on top of each other. The diagram is as much of an actual location of everything as possible. So with hoses and wires, they're stacked on each other, wiring looms, it's just basic stuff. So the schematic will actually have each one separated so you can trace it, follow it, because occasionally the schematic will tell you that this blue wire that comes down to here hits another connection point and takes off. It suddenly becomes a white wire with a red tracer. W/T. Get my drift? Okay, so what are we going to do today? A guy asked about, what's my diagram like? Well, we're going to start. Now, this works 12 volt, but we're going to go 12 volt anyway. Yeah, I'll stay 12 volt for this one. And obviously here I've made positive here. However, negative is going to be the ground. So what are we going to do with ground? Well, I'm going to do this partial diagram and partial schematic, what this is going to do. When you come off the negative post of the battery, there's an official... What the heck was it? There's 2 ways to draw a ground, and I forgot what the official is. So I'll draw what the common one is. It's like a triangle of dash marks. There you go. Okay, just there is one for frame. I know what it is. I forgot. I remember now. Here it is. Doop, doop, doot, doot, doot. There we go. I'll draw a different section and put both of them side by side. There we go. There we go. There we go. This one that's common, meaning earth ground, which they're saying battery is being grounded to the frame. This one is extracurricular grounds and the wiring harness on the other accessories to the framework, etc., etc. So that's the common difference between the two. Which one are you going to see? Almost everybody draws this as ground. So we'll go with that. Your battery is now grounded. We're working with a negative ground system, which is common. I'm going to pretend that this is a 12-volt conversion, okay? Or you have a 12-volt machine and the wires are junk and you're rewiring the tractor to run. Let's just say we're pretending it's my Ferguson TO35. All right. Now, coming off the battery, the first place you're going to go from the positive is to, most often, next to the starter or under the dash. Now, I'm going to draw it in a different way, however, but between the starter, we're doing a conversion, so the other is, this is your distributor, coil. All right, there we go. Now, you get my point here. You've gone to ground. Now we're headed right straight to the starter, but before the starter, solenoid. So all your power is going to be coming from the battery side of the solenoid. So we're going to make a loop wire. It's going to go around up to the key switch. Yes, I should have different colors. There's your loop wire going to your key switch. Pretty simple, isn't it? Okay. So you're drawing a picture of your own machine? I hope so. Hey, look, I only have one watching. It's 17 at one point. Not interesting enough. See this? I don't care. All right. Here's the next one. We're going to go loop around the steering wheel. No, we're not. We're going to go under it. Then we're going to go over here, and we're going to make a stop at the voltmeter for the fun of it. Then we're going to go from the voltmeter, the same terminal, and come down here to the ignition coil, plus. Okay, here you are. Down from the key switch to the voltmeter, down around here to the ignition coil, plus. Now, this is the same post. The voltmeter is just, it happens to be there. It's going to be a good thing to work off of. But voltmeters usually have very thin wires, so you have to probably make a post or a butt connection, union joint there someplace. Go into the distributor plus side. Why? Because the coil, I'm sorry. We're on to the coil, excuse me. But it's similar. Now on the opposite side, this is going to be the minus. And that's going to the distributor. There you go. I'll get it right yet. So there we come off the key switch to the voltmeter around here to the plus side, because this is all plus power. Plus side of coil, negative side to the distributor. Why? Because the distributor grounds the coil. This is the active part of the circuit. The distributor controls what the coil does and when. So that's why we're in that mode. Okay, your ignition system is pretty well done, isn't it? Well, sort of. Because on the other side, you've converted this to an alternator, correct? This is where it gets interesting. Now, the alternator has to have a hot feed of some sort. So you're going to run a wire from the alternator, just so you can see this thing come around. And you're going to go up here, and I'm going to do it diagonally to the hot side of your solenoid. You're going to put in a one-wire alternator here. Okay? There you go. Where am I? Stuff's all over the place. There it is. Alternator. Going around here, coming around and going to the hot side where the battery connection is for the key switch and the battery, all of them together. Well, that's crazy. Why in the world? We'll get to the rest later. That's what you do, because you have a one-wire alternator. If you have a 3-connection alternator, one of the connections is going to go to the hot here anyway. The other connection is going to go up here to the ignition side of the key switch. But it requires a diode or your engine will keep running. But we're going to do a one wire. It avoids all of that, okay? No extra plugs, no extra connections, just one. So you're doing a conversion. You're done. You're operational now. That's right. You're operational now. Oh, wait a minute. Not yet. Not yet. Why? Because the key switch ignition side has to do one other thing. What's that have to do? Okay, we're going to go across the top of the battery for lack of space. Goes to the third post on your solenoid. Key switch, third post of solenoid. Hot, starter operational side, and this is the third post for your key switch. And that has to have its own. You need a key switch with ignition and start. That's it. Now some of them have accessories. You can use key switches with 5 terminals, 3, 4, whatever. Oliver used to have one where the hot one was a beautiful one for as far as simplicity, but it was miserable to work with because they were all nut threaded solid terminals. And the center one was always hot. And then you had your start, accessories, and ignition on the others. So your key switch here, we're talking just simple. Power in, power out to ignition, power out to starter, 3 terminals. Your solenoid, simple. Power in, power out, main power in, main power out, and primary start wire from the key switch. It's just that simple. Turnkey ignition, that's going to fire up everything through your ignition system. Get your juice to your voltmeter, which the voltmeter is going to have its own ground. I'll put that on there just because. So the voltmeter just has 2 small, fine connections, high impedance. All it's measuring is voltage. It doesn't want amperage, just what's the voltage, potential difference between the battery as it is and when you fire it up, when the alternator starts working. So there you are. What are you going to do for a light circuit? Well, you can go off of several places here for the light circuit depending on what you want to do. Are you drawing the picture? If you are, then this makes it real easy. There's 2 ways you can handle the light. One of them is the battery hot side of the solenoid. Take juice straight off, put it to the light switch. You're going to put fuses in here, of course. If you're power to the main key switch, you want a good size fuse, 20, 30 amps. Someplace in there. But going to the light circuits, usually 15's enough. 10 to 15. If you're running LEDs quite often, like a 5 LED on the front and the back, probably 10 amp is enough. But check your amp rating, because some of those LEDs, high intensities, they need juice. But it's for a reason. So where are we going to take this off? You drawing your own diagram here? I hope so. You're going to come off the ignition circuit. Okay? Which is the backside of the voltmeter, but for the ignition circuit. So draw a line right past your steering wheel over to the light switch. Right, there you are. Now you're at your light switch. What are you going to do? Well, we're going to run exterior wires, but you know you're going to be interior. We're going to go around all this stuff because this is going to be partially a schematic. And then you're going to run another wire underneath the seat all the way to your back headlight. I have tulips in front and a round mesh screen in the back. There you are. Your light switch, power from the ignition to the key, running to this light, running over here to that light, and going to the back. Now, occasionally, what has been done on old tractors in the past is there will be an outlet plug off of here. It'll be right next to the light, so that you can plug in lights for your trailers. We used to have one trailer that had busted up lights on the back and a wire hanging in the front. And there was a socket underneath the tail light that was on the left side. As if you were going down the road, you'd see that red light. And underneath it was a socket so you could plug in and have at least 1 or 2 lights on the back end of the trailer to see. No turn signals, no brake or anything else. But it gave you an idea that something's coming down the road. you're looking at the back side of it because the lights are red. We had one trailer like that. So that used to be relatively common in the old farm days of the 50s, pretty much. So there you are. You have wired your tractor and it's now completely functional. You have lights, you have a voltmeter, you have your ignition system hooked up, you have your solenoid and starter working, you have your negative ground. So what do you do for positive ground? Well, you're not going to run an alternator. Let me put it to you that way. You might find an actual positive ground alternator. Alternators have diodes in them, and it's critical which way they go. Generators, believe it or not, if you suddenly decide you want a negative ground system and you're not changing anything else and you have a positive ground 6-volt system, you can change it, but it's not happy. The starter doesn't work as well, but it will work. The ignition system couldn't care less. And the problem comes in your generator. You have to repolarize the generator. And you can't just touch the wire like they tell you to the A or the G terminal on it. When you polarize most of your generators, what you're going to do, for me anyway, is disconnect the belt, but you don't have to. Disconnect the wires off the generator itself, or at least take off the A, but a lot of guys don't even do that. You take a wire from the hot side of the battery, run it down to the A for armature terminal, and hold it on there 1001, 1002, and that's it. Just quickly. 2 seconds is too long. Just 1 second is usually 1001 and release it. But that rarely works, believe it or not. Now, if you have a Delco generator, it's very easy. Once you've done that, you've polarized the thing, which it kind of does. You fire the generator up, it doesn't work. That's right, it doesn't work usually. You get a 50-50 shot in a good day that it works. Like, well, it was just working. What's going on here? Well, if you're trying to reverse things, it's not going to work right. So what do you do? Well, what I like to do is have my regulator completely disconnected. Nothing on the field. And we're still talking Delco now, which is a field terminal ground to operate. Okay? That's right. It takes out a little bit of internal power, runs it through the field coils in the case, and then comes out the terminal, and the terminal goes to the regulator, and the regulator grounds it. We're going to stay with that. Let's not fumble around with that one. You fire up the machine now, and you have your field terminal grounded with a jumper wire, because that's only going to pull 2 amps. So once everything gets going, you can't hurt it. You can have a good sized jumper wire, probably 10 or 12 gauge wire, or a small jumper cable hooked to the hot side of your battery, not the ground side, the hot side, and you're going to touch the A terminal for armature. You are. With a voltmeter hooked up either on that A terminal or on the battery. And then you're going to watch what it does. If it's on the battery, you can see where you're starting, which in a 6-volt, if you're maintaining that, you're going to be running 6, 6.3, sometimes 6.5. But usually it's a little bit less than 6.5, someplace around there, but between 6 and 6.5 volts. Fire your machine up, the voltage drops some, let it sit there, balance out for a second, and then touch the A terminal and watch your volts go up. Now, in generator, they tend to go slow. You'll see it start to just creep in and start rising up. And just let it go. Why? Because your generator's on full tilt. There's nothing regulating it. Your field terminal, the F, is grounded. This is Delco, ground field. And it's slowly raising the battery voltage up. Now, don't let it go over 7 plus. 7.5 is good. Some guys recommended 8 volts. No. 8 volts is problematic unless you're going out, you're just doing short runs. You go out, spread manure, and come back. That's all you're doing. It's not horrible, but it's not good. What you're looking for is your generator to keep putting out until it does get up to 8 volts or near it. But usually I stop when it's passing 7.5, because it starts balancing, getting the battery charge up and up fairly quick. And then it'll back off. The voltage of the generator will come up. The battery will come up. And it'll get to a balance point where there's enough charge in the battery that it's saying, yeah, I'm fighting back now because I have some balanced voltage. Battery volts start at 6, 6.3, 6.5, somewhere in there. You got this generator suddenly putting out 7, 7.5, which is equivalent in a 12-volt system to 14 to 15 volts. That's why it's not good to leave it at 8 volts long. You want to be at 7. 7 is 7, 7.25 is perfect. 7.5 is a little high, but they will function. For some reason, 6-volt batteries are a lot heftier than that, but you don't find them anymore. And the last one I had was pretty dang fragile, but it lasted years. My Ferguson operated perfect on 6 volts. Why'd you convert it? Well, because I wanted to put electronic ignition in it. That was one. So I changed the coil and changed the alternator. But in your generator system, if you're going to keep it, that's how you're going to watch your voltage rise up when you know it's charging. If you want to know its capabilities and your battery is doing okay, it's not boiling, there's no other hot wires or any other problem, keep it scoping on it, watch the meter, keep your hand away from the fan, just touch it or put a temp gun to it, make sure your generator isn't superheating or anything. Listen carefully for your bearings banging and squeaking around, because if they are, your generator's shot and you need another one. I'll just lube it. Not after it's making noise. Too late. I'll just grease it. Maybe. I wouldn't bother. But if you want to keep it original, that's up to you. Put a bushing and a bearing in. So you get up 7, 7.5 volts. The battery's happy. Everything's going along fine. The generator seems warm but not hot. You're golden. Now you got it. Now hook everything up properly. Shut the tractor off, of course. Hook everything up properly and fire it up. And see what happens with your charging. Well, it should snap to and start building voltage. You'll turn the key on, amperage in this case. I keep saying volts because that's what I operate on. But you watch your amperage. You turn the key on, think. Now, you'll notice, for those of you inexperienced, you still have points and condenser on your engine, 6-volt systems. You turn your key on, sometimes the needle goes discharge, sometimes it doesn't move. Depends on whether it stops with the points open, stays there, points closed, it discharges slightly. Tells you how much your ignition system is drawing when the points are closed. Points are doing this. So you hardly notice any drain on the battery once it's running. But the generator kicks in, starts charging the battery. The ignition system is, well, it's important to keep it running, but it's not drawn enough to make a real concern about anything. You can charge a battery up and run your machine without a generator working for quite a long time. But you'll notice that it skips and sputters more because it doesn't have voltage to maintain the wattage to operate the coil to get that nice hot spark on the other side. Now that you've done all of this, you fired your machine up and you got your regulator hooked up, you know your points condenser all right, your generator's working, you got that all scoped out, your wires are hooked back up, you're certain that your wires are hooked in the appropriate place because you usually have 4 terminals on your regulators and sometimes only 3. There's gen, field, and bat are your main ones. And on some other, you'll have load. Load is L, which a lot of older tractors use that. Rather than taking off the separate solenoid on the starter, some of them use load on the regulator to operate the key switch and accessories in the ignition system. Right off the regulator. It was a common deal. But the 3 are the main ones that you need. Battery, generator, and field. So fire it up and see what it's operating to. Let it run for a while. Now, if you have lights, turn them on. Now watch what happens to your amps. They'll drop, but do they stay up high enough? And if your lights aren't overloading anything, they're just, let's say you have a generator capable of 10 amps, you have 5 amps worth of lights, what you'll notice, you'll turn the lights on, and the needle will drop and come right back up. You'll notice when the battery is low, you've cranked too many times in the winter, you ran out of gas, or you flooded it, etc., or it's been sitting quite a while, you'll notice that when you're cranking, that ammeter will do some funny things, and when you fire it up, beep, and you turn the lights on, it goes way down. Yeah. Why? Because the thing isn't fully charged here, and it's working hard to charge the battery, and there's not much left over to run the lights. The generator is beating itself to death. So you have to watch that stuff too while you're doing this. All right, so now you've got your tractor wired, you've got some lights on there. Now remember also, if you're keeping your generator, remember they rarely have a generator that's over 15 amps. You'll get a few that are 20, but it's rare, especially on a 6-volt system, to ever go over 20. Don't ask me why, but they kept them small. The tractors are small, trying to keep the parasitic load down because you're working, you need a battery charged. They don't use lights very often, so they kept it fairly small, 15, 20. And I can't ever remember, but I'm sure there's some been around that went 25 amps. That on the larger diesels, you're going to start seeing some 30, 35 that are generators. What a waste of time that was. But that was the common thing. How do you make a bigger generator? Longer armature, longer fields. A little bigger armature, a little bigger fields. But you notice that even the larger generators, they're bigger, but not that much. You notice on some alternators, they're 100 and some amps. Lee Neville's, these little dinky things. And then you have the huge truck alternators. This big, 90 amp, 110 amp, 120. But then down here is 125 ampere efficiency. So a lot of guys used to put those monster Lee Neville's because they were dirt cheap. I mean, dirt cheap. But I helped a guy put one on an 1855 Oliver one day. You want to talk about a disaster. I think he drove back and forth to the local Napa store 5 or 6 times, and it wasn't like it was, a couple miles down the road. This thing was like 10 miles out of, where were we out of? Oneonta, I think. We were south of Oneonta somewhere. He kept driving back and forth till he got a belt to fit, and he said, for all the gas I just burned, I should have bought a whole set of them. So we hooked it up, wired it up, and I pulled a nut off, and I tossed the lock washer. I hate the things, so I even forget about them. And he says, what are you doing? I said, electrical fitting. I said, and I was only 25 at the time, maybe 26. He said, what are you doing? I said, throw them away. So what are you talking about? I said, every electrical connection I've ever seen a lock washer on, they overheat, they rust, they rot. The crack that's in the washer allows moisture to get in there. I've always had trouble with them. Never again. I put little Never Sees on it. He says, you need to put dielectric grease on there. No. Excuse me. He says, why not? He says, you're talking a 12-volt system. Where's it going? It's not like you're putting Never Sees all the way down the terminal on and grounding it across the little insulator shoulder and onto the thing. Just a little dab on here. And he sat there and he says, you know something funny now that you mention that? He says, they handed me the alternator. It didn't have a lock washer on it. I put one on it. He said, they said the same thing you did. No lock washer has ever helped an electrical connection in history. Well, yeah, you put a star washer on. No. Star washer is even worse. They use that on some ground connections directly to a block to dig in and try and get at the factory to be sure they get a good ground. You clean that eyelet off, you clean that block off, and you put that straight in with no lock washer on there. Only occasionally, if you have to use an eye on the end of the wire too big, you put a flat washer on. Other than that, nothing. Just let iron be iron and metal be metal. Why? Well, one guy told me years ago, and he was a physics teacher off the farm. He was a farmer that went to school to learn how to teach and took physics with him, started teaching physics, and an actual PhD physics teacher that was my guidance counselor, so to speak, there at the college, the SUNY Cobleskill Ag Engineering Division. Ken Alcott says, I've never seen anybody that just fell into physics. And he says, because of his farm background, he keeps teaching me. And he says, it was frustrating at first because I kept saying, no. And he says, you didn't grow up on the farm, did you? He says, the farmer was patient with me, teaching me reality. That was his name. Gordon Walsh. So old Gordy, 6'6" of them, would be walking around melting wires, burning wires, and teaching us stuff. And on the starter circuit, he said, every connection is 1/10 of a volt. And we looked at him funny. He says, every connection is 1/10 of a volt immediately. And that's if it's a perfect connection. So your battery terminal hooking onto the battery, 1/10 of a volt. If you put a wing nut with a wire and an eyelet on that connector, that's 1/10 of a volt. You go to the starter, or to the solenoid, that's 1/10 of a volt. You go into the starter itself, that's another connection through the solenoid, 1/10 of a volt coming out. And he didn't even talk about that one. That was just an obvious one. But we were hoping that one, we were trying to say it was 0. But on the outside, 1/10 of a volt going to a starter stud sometimes, 1/10 of a volt. So how many tenths of a volt did you just lose on your 6-volt system trying to crank that battery? With the battery saying it's 6.5 volts, and by the time you turn the key, there's a power draw, so it brings it down to 6 volts or below. And then at the same time, each of those connections it has to pass through, let's say, for the sake of brevity, 5. That's 5/10 of a volt. What is that? That's half a volt you lost. Before you even turn the key, you have a half a volt loss. It's that simple. Now you go measuring through it with your ohm meter, and that's not a problem. No, it's not. Your ohm meter will never show you that loss until 200, 300, 400, 500 amps starts crossing that terminal. Then you get voltage drop because there's insufficient connections for it to pass through perfectly. It's just something we live with to make things convenient, easy, and direct. Otherwise, you'd have batteries come out with wires hanging off of them to go almost all the way to the starter, and you'd cut the wire to fit. Imagine the cost of that. So they make connections. The best connection, if you're going to convert something that's, I'm going to say 60 horse and up, 65, it's 65, somewhere in the 60 to 70 horse range and up. And you got a nice size battery in there. If you can get a good size battery, group 30, 31, get the posts like the over-the-road trucks. What the? Yeah, get the posts like the over-the-road trucks. I don't know if you can get them on smaller batteries or not, but they're a better bet. They work better than trying to, or I should say the studs, I'm sorry. Get the studs. They're 3/8 studs to hook up. And the basic is commonality. It's easier to repair the wires. You don't need that big, huge lead or brass terminal to stick on there. And when you clamp it down, the thing sometimes slides up the post and all kinds of troubles with those things. They pass energy a little bit better. But in a reliable and clean sense, that stud and that eyelet and that stainless nut are going to last a lot longer and a lot better. So what I did with one farm I was at, because we just couldn't keep anything in there, literally, and this wasn't good, but it worked. We had post batteries, so I would drill the post and tap it for 3/8 bolt. And then as the batteries died, I had wires and everything designed for it. You can only go in there about that far. Don't be stupid. You need a little bitty short 3/8, a 1/2 inch bolt. But I converted it over so it would operate like studs. Bolt the thing in. When the battery failed, put post batteries in. And a lot of problems completely disappeared. And the other one was, when he went to hook up jumper cables, there were 2 stainless nuts sitting there. Simplified a lot of trouble on that farm. That was a farm in psychosis right there. Cornell grads, too. You ain't Cornell grad. What the heck you talking about? And I looked at the one fella and said, no, I went to Cobleskill. And supposedly, from what I heard, I learned in 2 years what Cornell took 4 to teach. So going to Cornell was a waste of time. In fact, every employer I ever had said the same thing back in the early 80s. I graduated in 1980, SUNY Cobleskill. So just to give you an idea. And in part, and Ken Alcott, the PhD guy, said the same thing. He says, these are the best instructors on the planet, but because they don't have the PhD or the master's degree to go with it, nobody will ever believe it. And they wouldn't accredit the program all the way up to where Cornell was because they weren't smurfified. Oh, trust me, they had the arrogance to go with it. But it's Rush Limbaugh. It's not arrogance if you can deliver. And they all delivered except one. One had a mouth and no capabilities. I'll leave that alone because most people know who I'm talking about. Then later on, there was another one that had a PhD and a mouth. And the immediate thing he did was start arguing with me on a tractor I just worked on. I said, yeah, I know what that is. What is it? I said, the 70 series case. Yeah. 770, 870, 970, 1070. Yeah, I know that. I know that valve right there. It's pilot operated relief. It's in two sections. Yes. This is the main and this is the pilot. They're just showing it in two parts of the picture. It's functional, so you know how it's operating. This is a diagram, not a schematic. What's a schematic? That's a... What are you talking about? I just worked on one 3 days ago. You're talking to the wrong guy. And he went off. The former hydraulics teacher happened to come in, picking up a few other things as he was going out. And he looked at it and stuttered and stuttered. And I was like, come on, Oscar. It's a pilot-operated relief valve. I muttered. Some other kids are giggling. Oscar says, I know what that is. That's got to be a pilot-operated relief valve. They're just showing it in two parts. I said, no kidding. Same problem. PhD is a problem in arrogance. I'm up here, you're down there. And I got through with the program with only, as far as I knew anyway, only one PhD guy in there. Made a huge difference in how I learned. Not Cornell accredited? No. It was real world farm accredited, let me tell you. When they taught you about the Baylor knotter, they probably fixed one. No, actually, that teacher didn't. He had a master's. I don't think he had a PhD. Old Don Demick. But he taught it for so long, and he talked to other guys that had fixed it. He had an idea what was going on, and he wasn't stupid enough to stick his neck out there and tell you precisely how to fix everything, because his shop foreman guy knew more than he did about it, and he let him do the talking. Just saying. And how do I know? Well, he sat there one time and he says, on that question, if you come to my office and you show me where it is in that book and you prove me wrong, I'll give you the answer. Well, okay. John Deere FMO, Fundamentals of Operation. I showed him where it showed me a picture of the wrong way to sharpen a knife. It doesn't say it's going to be, no, it says it's sharpened improperly. Sharpened improperly means loss of horsepower. Also means loss of efficiency, and also means it doesn't cut, it smashes. It says back in here, improper sharpening causes. This is the picture of improper sharpening. He says, you're the only one. He said, I think he said he had almost 10 students come through. He says, you're the first one to point that out. He says, you'll get it. I'd appreciate it if you didn't tell the rest of them, though. He says, they just came in here blowing smoke and yelling. Well, it's because he did a lot of smoke blowing and yelling. They called him out of retirement because they didn't have anybody to cover for him. They ran out of teachers that knew what they were doing. So that's how much you put your time into this and your effort and learn. But I'm putting it out here because what? I'm an old fart. I've done this. I'm 65. I'm an official geriatric, baby. And by how many days? What is it? 14th today? So it'd give me 12 days as a geriatric. And I've had the senior tag for 10 years now. And why am I retired at 65? I love what I do, and I wanted to work on Kubotas until I was at least 65. But the company I work for at Empire Tractor, which is gone now, is a bunch of narcissistic jackasses. Didn't give a crap about their people or their employees. Highest guy in the shop, when they were charging $130 an hour, got paid $25, and he hadn't had a raise in years. Now, I had left Anderson Equipment because they hired 4 morons in a row. 4! I mean, we're talking belligerent, arrogant, chasing customers away. I mean, out of control. But they liked the attitude. Didn't help us serve the customers. And I left there making almost $30 an hour while they were charging $120 to $130 an hour for construction equipment. Komatsu. I sat there and looked, said, you guys are charging $130 an hour and you can't pay over $25? The company doesn't want to pay it. You guys aren't worth it. Bull, we aren't worth it. You're charging it. And the service writer says, you think? There's a lot of money that comes in this shop. Not much going out. And there were tools that weren't repaired. We had a couple of downtimes because the customers were perturbed and went elsewhere for some things. And I sat there and spent almost an entire week trying to hoe out the tool room. Guys were screaming for this, screaming for that. And I said, yeah. It's all stacked in the corner. I separated it. It's over here in the bucket. What do you mean? It was just thrown on the cart. I said, yeah. But they were test hoses. Individual test hoses. They didn't go with a flow rater on the flow rater cart with the flow rater parts. He says, oh, so it's over there. I said, yeah. Oh, there it is. And he pulled it up out of the bucket and walked away. He turned around, looked at me and says, so now I can run the flow rater out here and the cart will actually roll? Took over 100 pounds off the cart. Junk. And that's the kind of outfit they were. So my back was hurting. I had a bad knee on top of it. I'd had a hernia repair from years ago from coughing my face off, getting in the flood mud, cleaning up Anderson equipment like 12 times. Finally got caught in the flood mud, wrecked a lung. I retired. And that was at 62. Be 3 years this October. I actually wanted to go until I was 70. I loved the work. I was enjoying Kubotas, putting them together, assembling and Power Beyond stuff and extended and loader valves and the kits that were going on them, and it didn't matter. What was the one? 100 and something, 130 horse or whatever, put a loader on. It's not a real 130 horse. It's 130 horse at the flywheel. Go out to PTO. Maybe you'll get 115. They had one, the tractor was rated 70 horse. At the PTO, well, it said 111 or something like that. Yeah, I think it was a M4 series, 101. And the PTO barely just made horsepower. Had a flat torque curve, so that's it. Went to horsepower, you could lug it down and it just kind of stayed there quivering. It's not like I used to put the Alice Chalmers on the dyno. They put a 200 on the dyno and start turning the wheel and bring it down to 540 and just running 120 horsepower. Just putting a nice light haze out. Two different categories of machinery. Doesn't mean the Kubota's bad. It's not what we had in the 60s, 70s, and 80s. Different world. And that's what this is. The different world. Now, if you want to convert this is my last thing I'll get because I got 43 minutes in here. Last thing, you want to convert this to 12 volt. Well, I just told you how to keep it at 12 volt, but if you want to keep your 6 volt, your coil needs to go to positive ground for most 6 volt systems. Who was it? Oliver had an interesting thing. If it had a generator, the voltage did not matter. It was always positive ground for generator. Always. All Olivers, always positive ground for generator. Unless, of course, it was the Fiat versions. That's a different world. The 65 series, 1465, 1265s, etc. Yeah. The weird, funky hoods, yeah. That's Fiat. Everything goes out the window for that. Magneti Marelli, you'll get Bosch, you'll get used to those names of those tractors. But your actual American build Olivers, everything with a generator was positive ground. Everything with an alternator, which of course is 12 volt only, is negative ground. That's an easy one. You want to convert to a positive or a negative ground and you had an old positive ground machine, I would recommend putting an alternator on there. Next thing is you take your coil and turn it. The negative side of the coil goes to the distributor. If it's not marked and you don't know what it is, you pull it out and throw it away. You heard me. If you're converting voltages from 6 to 12, you go down to your local Napa. Don't go to many other places. Standard, that's what I can never remember. Silver Streak, Standard Motors products off of Long Island. That and Napa's Eklund stuff. They're the best that's left. Some of you are going to balk at Eklund. I know, I hear you. But that's what we're stuck with now. But either way, go to one of those stores that provides those types of parts. Even on Amazon, you can find the Standard Motors products. And you want to get a 12-volt coil without an external resistor. So if you're converting one of these things and you put this coil in, you take a new wire from the key to your coil. And you get it for a Kohler engine. The old K series, K241, K301, K321, K341. You say, why? Because it's an engine that was a flathead, that was high compression, high torque, and ran at over 3,000 RPM. So that single cylinder against your old tractor that's barely going to turn 1,800, and most of the time be running 15 to 1,800 RPM, trust me, that coil's going to outlast you. And your engine is lower compression, high compression, needs more spark, lower compression, less spark. That's another thing, that factor to build in. That coil will last you just fine. You don't have to go anywhere else to look at anything else. I want an old Kohler K series coil. But that's, just tell them to stop. I want a Kohler K series coil. And one guy looked at me, oh, you just want a coil that doesn't have an external resistor? I said, yeah, that's what I said, the Kohler K series coil. Oh, yeah, I know what you want. Wait a minute. Numbers don't match. Yeah, that's why I'm asking for the Kohler K series coil. Now, if you get into some of these other Steiners and Yesterday Tractor, Kuhns and such, and they have that type of one wire, or that type of no resistor, no external resistor coil, that would probably be okay, but I'd stay with the standard in the Eklund. It's a whole different world than the Kohler K series coil. If somebody says you can get an OEM coil, knock yourself out. I bought the stuff originally at Tractor Supply 20 years ago, cooked them the first time out, burnt the points, and the coil almost blew up. And I had an alternator with confirmed 14 volts and a good battery. Cooked them, bucking and snorting, and the tractor has enough trouble with that because I think I have a crack in my manifold someplace. Every once in a while, I think fires up perfect. So a sticky valve or crack in a manifold, something. And then once it's going, you're good all day long. So that's what you do when you're changing from positive, negative ground. Turns your coil, repolarize your generator in the full manner that I mentioned before. And if all you're doing is, if you're doing the 12 volt conversion, then that changes the coil completely out of there. Your points of condenser will operate fine. Yeah, that's the weird thing. But that's 12 volt, but the internal resistance and the spark that's going out the other side have to be the same, right? Got to be the same spark in the engine. So this coil might be 12 volt, but it's wired to operate and give you the same spark or a little hotter out the other side. So that's why you get it with the internal resistance, is the internal coil wires. What was the external coil for? On the Ford 8N, that's a different story. For some reason, they had a coil that could only take up to about 5 volts. Anything over 5 volts, you start cooking it. Why? I don't know. It's just what they designed it for, because the original coil was an oil filled. It didn't like heat. So some of the guys would convert them to, you could get a coil that didn't need a resistor, I think, but most of them would convert it to a 12 volt coil that didn't need the resistor. Problem solved. 12 volt tractor. Put your alternator or a 12 volt generator on there. Makes a big difference in spark. So with this thing, starters, you can't do much with a starter when you do your conversion, positive, negative, whatever. It is what it is. But if it's a 6 volt starter, positive ground, and you put a 12 volt system on there, if you want to spend the money for a 12 volt starter for longevity, if you're doing a lot of starts and stops, I'd recommend it. But if you're one of those guys like me that go up and you cut a little firewood once in a while and you're playing around and you start and stop the tractor a few times, the nice thing is that 6 volt coil with 12 volts hitting it in the winter time is a perfect match. I get up there and it's 20 degrees or below and I got a small battery, but I have a 6 volt starter and I hit that thing, woohoo, she's gone. And the Pertronix ignition that I put in the distributor, that makes the spark a heck of a lot better. Pertronix. If you follow the instructions, you'll see how they want it wired, which is odd, but it works perfect. They'll tell you to put the points and condenser in, get your ignition system timed, the point set, the ignition timed properly. Now, for me, that's easy. On my Ferguson, you get the points nice and clean, gap at 20 thousandths, turn the engine over to top dead center, loosen the distributor, know which way your rotor is turning. If your rotor is turning clockwise, then you turn the distributor a few degrees clockwise and then start back. until you get a spark out of your coil wire. Then you put your cap on and you do it, back it up again, take your number 1 spark plug out, put it in the wire and ground it to the side of the block, and then again turn it until your number 1 goes tick. And sometimes points get dirty and you'll hear the tick in the distributor, but it won't be across the spark plug unless you turn it. Why? You're confirming that you're timing on number 1. That's the first thing. So that's important. Strangely enough, on a 4-cylinder, you can time static timing. You can time number 1 and number 4. But I don't recommend it unless you've done it before. So static time with your coil wire first. Then put the spark plug out there, cap on, and static time to number 1. Be sure you're on number 1 is all that's for. Then once it just turn it, tick, lock it down. And if you're really concerned, turn your flywheel backwards, either with a fan or with the teeth, and then turn it slowly forward until you hear it tick and line up your timing marks, either in the back or the front. See how close they are. If you're within a degree or 2 on these old engines, you're golden. You got it. Now put your Pertronics in there. And your Pertronics will be immediately timed. You don't have to time the distributor, don't have to look at anything else. Just drop the plate in, wire the thing up, and turn your key on, and go have a nice day. Done it twice. Ferguson first, and then the 511B case next. They're both Delco distributors in these. Sometimes they have auto lights on the case, in case you don't know what you're going to get. But Ferguson's almost 100% Delco. Unless they come from overseas, and then you start seeing Lucas. Ah! That's a headache in its own right. So hopefully that helps some of you guys. Go back through this. I'm going to try and do something a little brief and break this up a little bit more later, where your 6-volt and a conversion, your 12-volt and a conversion, and for those who want to maintain, how to do that. And alternator changeovers, what it might take. But hopefully this is enough for most of you. If you hung around here, hopefully what you're doing is you're out in the kitchen making a stew, or you're fixing something else. Just listen to me prattling and rambling on here and showing your funny little chicken scratch on the paper. All right, I got to get going. My day needs to start here shortly. What time is it now? It's 9:33. Time for me to hook up my trailer. I have to go pick up a lawnmower. A John Deere. And John Deere never does anything normal. If you're going to buy a lawn tractor, never buy a Deere, ever. Especially once they're up over, say, 12, 14 horsepower and they start getting into the exotic Kawasaki's. Don't. Just don't. They did the Sears thing that you old guys would know about. Sears used to buy engines for $8.50, $9.50, $10.50 from Tecumseh. It's a true story. There was no parts. Tecumseh didn't have to provide warranty. Tecumseh didn't have to provide parts. Sears would put in an order. They'd build what they wanted because Sears had the engineers. They had carburetors of wackadoodle you couldn't believe. Just weird, wacky. They had one that was turn it, this little dude on the side of this teeny, scrawny, long little carburetor. Choke. Once it chokes, fires, and gets running, you turn it to run. Well, run is an open hole straight through, taking gas in. How do you shut it off? You take the same plastic dinger and turn it until that funky little C is in the front instead of up here or over here for choke. Cuts it off and stalls. No governor. That was it. Big gutless 3 horsepower. Yeah. They found out inadvertently that there was a minor governor action as the engine slowed down because of that small little orifice in there that was made by that doodad, because it cut off half the hole. It'd make a vacuum on this side. So, one side was a little off a little. But anyway, what the idea was, they found out as it slowed down, when the piston went down on intake, there was more time for more air to get through that little narrow restriction. So more gas went in too, and it would act sort of like its own governor. Yeah, it didn't last long. But you know why they did it? They'd sell you an entire lawnmower. All you had to do was fold the handle up and maybe put the wheels on for $30. American made. $30. And Sears couldn't sell enough of them. On sale today, $35. Regularly $50. They've never been $50, but they will be next year. Oh, yeah. Right next door to Ron Popeil, you know what I'm saying? I know, you have to be an old guy to catch any of that. Anyway, you folks have a good one. We're coming up near an hour that I've played in here. And I love telling stories and going along with this stuff because I got, for crying out loud, are you kidding? There was one of the very first rotary mowers ever sold in the United States of America. In fact, anywhere in the world, was sold through Agway. And I forgot who made the mower deck. It was aluminum. And we bought one with a little, I can't remember what it was, Model 6 or something, vertical shaft, Briggs & Stratton. And my uncle finally put some wheels on it, tried to get it going. He never could get it going right, never figured it out. And it sat there for a year or two. So finally, I was a little kid that wanted wheels for, I was taking milk crates and putting axles and wheels on them, and I wanted to get a calf or two and tow my wagon around, like wagon train. So I went down and I had these little pressed metal wrenches and took the wheels off the mower and stuck them on my doodad. I was 4 or 5 at the time doing this stuff. They were trying to figure out, they'd be screaming, "Virginia, are you watching those kids?" And wires were pulled off the distributor. They couldn't figure out where to put them back on. Key switches left on. Tractor and manure spreader were suddenly 30 feet backwards from where they were, half jackknife, because I was shifting the thing and playing with it and didn't put it back in gear. They didn't lock the brakes very often. Who did this? That was a 5-year-old missile. I don't want to go to kindergarten. I want to bale hay with Daddy. That's my world, folks, from 1965 on.